This lesson is on the natural log, arcsine, and arctan rules for the derivatives. So we're looking at the shortcut rules for these three functions. And those rules are right here. The derivative of natural log of x is 1 over x. The derivative of arctangent x is 1 over 1 plus x squared. And the derivative of arcsine x is 1 over the square root of 1 minus x squared. Now, obviously, all of these have a plane x, and if the x is not plane, we always need to do the chain rule. So we will write this rule that we have, and whatever our x is will go in the place of the x here, but we will multiply by the derivative of that afterwards to do the chain correctly. So these three rules are your basic, but again, a chain rule could apply. So we'll come down to our examples. Our first example, y equals the natural log of x squared plus 1. Okay, so this derivative, natural log is the outside, and then this is where the x would be in this rule. So I'm going to use the natural log rule and say 1 over whatever there is in parentheses. So I have 1 over x squared plus 1. And that completes the natural log portion of the derivative. Then I'm doing a chain rule because this is not a plane x, so I multiply by its derivative, which would be 2x. For our second example, we have a product rule where we are multiplying x squared times the natural log of x. So the x squared will be our first piece, the natural log of x will be our second piece. And this is a plane x this time, so we won't have to do a chain rule with that. So our derivative will be first times the derivative of the second plus the second times the derivative of the first. It's just basic product rule there. Okay, for our third example, we're going to start to use that arctangent rule, and that arctangent is the outside focusing thing here. This inside is where the x will be in the arctangent rule, and we'll just put it in, and then we will multiply by the derivative of what's in here. So it's kind of a chain rule here. Do the arctangent first, so 1 over 1 plus x squared. Except because this is not a plane x, I fill all of that in. And that is completing your arctangent rule. Then we move to the inside and multiply by the derivative of the inside. The first part is a power rule, so you have 6x. The second part is your exponential rule, so you have e to the x times natural log of e, but we don't normally put that again because that's 1. I want to keep that in parentheses though because of that plus. If I don't, I'm not multiplying by the entire derivative, I would just be multiplying by the 6x, which is not correct. Okay, for example 4, we're going to be using our arcsine rule, and then it will be chain ruled because this is not a plane x. So I'm going to use my arcsine rule first, 1 over the square root of 1 minus whatever my x is squared. And my x in this case is 3 times 5 to the x. That is taking care of my arcsine rule. Then I move to the derivative of the inside. So the inside is an exponential rule, but I have that 3 that I need to bring down. It's not a product rule because the 3 does not have an x with it. So I just bring the 3 down, and then I do the exponential rule with the 5 to the x. So 5 to the x times the natural log of 5. Okay, example 5, we have again the arctangent rule and a lot in there, but again all of this serves as the x in the arctangent rule. So we'll do it first because it's our outside thing. We have 1 over 1 plus whatever our x is squared. Our x is everything represented here, so natural log of x minus 7 sine x. That takes care of our arctangent rule. Then I'm going to do the derivative of the inside and make sure I have it in parentheses. So the derivative of natural log x is 1 over x. Then I have a minus because the 7 is multiplied with sign and it doesn't have an x, I'm not doing a product rule, I'm just bringing the 7 down. The derivative of sine is cosine. So I've done the outside and I've done the inside. Okay, for example 6 we have another composition, and so we'll work from the outside in. First of all, our arcsine rule we're going to use, and then where we normally would put x, you have the tangent of x. So my arcsine rule is 1 over the square root of 1 minus x squared, and I'm going to fill in the x as tangent x. That completes your arcsine rule. Then you do the derivative of the inside. So the derivative of tangent is secant squared, and that completes the inside. So outside, inside. For example 7, I did a double layered chain rule type situation where I've plugged in and plugged in. So you just start on the outside and work your way in. Each time that you do one of the rules from the outside, what's in parentheses after it should not change until you get to that very last step when you're doing the multiplying by the derivative of the inside. So the derivative of cosine is negative sine, and I don't change anything inside at that point. All that stayed the same. Just went from cosine to negative sine. Then the next layer is natural log. So times it by the derivative of natural log of this, which will be 1 over whatever that is. And now that takes care of the cosine, that takes care of the natural log. I move to the inside, and I'm finally on the very inside, so multiplying by parentheses this derivative. So the derivative of 2 to the 7x would be 2 to the 7x times the natural log of 2 times 7, because that's an exponential with a chain. And then the derivative of tangent of x squared, derivative of tangent is secant squared, but I still have an x squared at that point, and then I'll multiply by the inside, which is the derivative of x squared is 2x. Okay, for example 8, we have this all under a square root, so you have to remember, if you have that, to view that as a 1/2 power. So I'm going to rewrite this and put that as a 1/2 power, and then take that derivative. So this will be a chain rule. I need to do the 1/2, whatever's in parentheses, to the negative 1/2, and I'm just going to copy that down. And then I'm going to multiply by the derivative of the inside. Again, make sure you put this in parentheses just in case that you have a sign issue. The derivative of 1 is 0. This is not 1 that I bring down because it's not multiplied by something with an x. It's added. And so when a number is added, you take its derivative. The derivative of that is 0. I'm not going to write 0 down. Plus, obviously 0 plus, I don't need to write down. Natural log rule is 1 over whatever comes after it. So 1 over 1 minus x, and then I have to do the derivative of the inside, which would be negative 1, and I'm multiplying by that. And so that is our final example, and that concludes this lesson.